All right, so Pascal's triangle is what you're looking at right here. Blaise Pascal is his name. And the triangle almost feels like Fibonacci's sequence, the way that it is built. It's based off conceptually the same thing, where you have the 0th row. The first row is just ones, and then all the outsides are ones, and the insides are created by the two above it added together. So 1 and 1 is 2, 1 and 2 is 3, 2 and 1 is 3, 4 and 6 is 10. So you can see that that's how you create each row. All right, so we start with ones, and then we go from there. Ones on the outside, and everything else on the inside is added by the two above it. All right, and this is Pascal's triangle. How it helps us is expanding binomials, okay? And so binomials, just, something plus something inside of parentheses, right? Or minus. To the 0 power, well, that's always just the 1, right? And then these guys to the 0. And what they found is they start expanding these. It's not bad if you have to FOIL it once or even twice. But if you have to do this thing 4 and 5 times, it's a pain, right? It's like over and over distributing 4 and 5 times. It's ridiculous. And so what they started noticing is that it goes in a pattern. The coefficients of these guys go in the Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. All right. And so the coefficients start going in this pattern. The other pattern that is erupting here, and I'll make it a little bigger. So let's move this guy out the way. All right. The other pattern that is coming is the exponents of your terms. And so we have the terms a and b. Well, on the 0th row, they're both to the 0 power. On the next row, it starts with a to the 1st power and goes down. B starts at 0 and goes up. So if we jump all the way to like the 4th row or the 5th row here, or 4th row, whatever, either one of these, the coefficients are in Pascal's triangle. 1, 4, 6, 4, 1, right? And then notice the exponents. A to the 4th, a to the 3rd, a squared, a to the 1st, a to the 0, right? And then notice your B. It starts at 0, 1, 2, 3, 4, all right? And so instead of foiling or distributing 4 or 5 times, you can literally just go straight to this expansion and then calculate what you need to calculate in case there's coefficients already in there, all right? So let's do a couple of these. Expand a sum. Look at the top of page 629. They want us to use Pascal's triangle to expand the binomial. All right. And so the 7th row of Pascal's triangle, you have to build on it. So they have given us the 6th row, right? They've given us the 6th row here. All right. And so we need the 7th row. And if you look, they gave us the 6th row. And when you add those together, you will get the 1 in front. And then you will get 1 and 6, which will be 7. 6 and 15, which will be 21. 15 and 20, 35. 20 and 15. 5 and 6. 6 and 1. And of course the 1 on the outside. All right, so you'll notice that it mirrors itself in, is what it does on these lines here. All right, so we have our coefficients. Now we just need to set it up. All right, so we start with a 1 and a to the 0. A to the 0. Wrong. The 7th, b to the 0. We're going to add to that our next coefficient, 7. And we're going to go down 1 with the a, up 1 with the b. Next coefficient, 21. Down 1 with the a, up 1 with the b. Next coefficient, 35. A to the 4th, b cubed. And we're going to keep going until we get a all the way to 0 and b all the way to 7. And instead of multiplying 7 times here, we will just have to simplify this when we get to the last step. Now, for this one, it's very simple because you have an a and a b and you do not have any coefficients on the a and b. The only thing you really need to simplify are these to the 0 powers. Those are just 1, and so you don't want to actually write to the 0 power. So you would want to write this just, and you don't even need to write the 1 in front of it. just a to the 7th. So you would just want to write it out without those numbers that are unnecessary, like b to the 1st. I don't need the 1st there. B to the 1st is just b. And so writing it without the unnecessary things, there's really all you have to do to this one to simplify. The next one is a little bit more, because what's different between the next one and the first one that we had? B and A. We have coefficients and we have actual numbers there, right? So we have a coefficient in front of our first, and the next one is a number. And so because of that, we will have to simplify even more, all right? This is to the 4th, so it's not going to be quite as large. Our 4th row is much smaller. It's 1, 4, 6, 4, 1. All right? So a much smaller expansion here, but we do have things that we're going to have to take up to that. And so when we expand this one, we're going to use our coefficients, right? And then we're going to use our A and our B. Well, our A and B is different. Our A is 3x. So we're going to say 3x to the 4th power. And then our B is now a 2. And so we're going to say 2 to the 0 power. And we're going to do that all the way across. We're going to use our next coefficient. We're going to say 3x to the 3rd power and 2 to the 1st. 6 and 3x squared. And fill this all the way in until we get 3x to the 0 power and 2 to the 4th power. Now, when we simplify this one, we are going to have to actually take those to the power, including the numbers themselves. And so it's going to be a little bit trickier than just making sure you don't have zeros and ones in there. So when I look at this to simplify it, I have 1 times 3 to the 4th, right, which is 81, times 2 to the 0, which is 1. So I have 1 times 81 times 1. And so I'm going to say 81 there. And then I have that x to the 4th power, right? Here, I'm going to say 3 to the 3rd power, which is 27, right? And then multiply that times 4 and times 2. So I have 27 times 8, which is going to give me 216. And then I have x cubed. For this third one, I have 3 squared, which is 9 times 6 times 4, right? So I have the 6 times the 3 squared, which is 9, times the 2 squared, which is 4, which actually gives me 216 again. For this third one, I have 4 times 3 times 2 cubed, which is 8. 4 times 3 times 2 cubed, which is 8. So I have 96. And then x to the 1st power. And then for the last one, I have 1. 3 to the 0 is just 1. 1 times 1. And 2 to the 4th is 16. So 1 times 1 times 16. And it's x to the 0, which is also just 1. And so that would be my expansion for 3x plus 2 to the 4th power. The difference here is that you are subtracting, not adding. It really only makes the difference when you take that second term to a power. Because if it's taken to an even power, it's going to be positive, and if it's taken to an odd power, it's going to be negative. And so what you'll find in these is they flip-flop positive, negative, positive, negative, positive, negative as you go, because that 4 is taken to a power, and it's technically a negative 4. And so you can actually think of it as like plus a negative 4. And so you're going to do the same thing. You're going to use your coefficients for your 5, which is 1, 5, 10, 10, 5, and 1. And then you're going to do your first term to the 5th power. And now your second term is negative 4y. And so as you do this, the negative 4 to the 0 is just positive 1, but negative 4 to the first power is going to be negative 4. And so when you multiply that group out, that becomes a negative group there. And then the next one is negative 4y squared. Well, negative 4 squared is going to be positive, and so that group is going to be positive. And so as you go through this, you'll see it just flip-flop. Cubed is going to make it positive. To the 4th is going to make it, cubed is going to make it negative. To the 4th is going to make it positive. And then this last term is going to be negative because it's to the 5th power. And so just pay attention to your positives and negatives if you do one of these. That's the most difficult part, is paying attention to what's happening. When you simplify it out, what you'll notice is I have a positive x to the 5th, a negative 20 x to the 4th y, positive 160 x cubed y squared, a negative 640 x squared y cubed, positive 1280 x y to the 4th, and a negative 1024 y to the 5th. So the only difference is your positives and negatives. Go ahead and try just A. Just A. All right, check your work. So 2x minus 7 to the 3rd power, you should have used the 3rd row. 8x cubed minus 84x squared plus 294x minus 343. All right, the binomial theorem uses a different method to come up with those coefficients. So where you can use the Pascal's triangle to do the coefficients, you can also use the binomial theorem. It says that you're going to use the combination, which they've reminded you of the formula, but you can also use your calculator to do it. N factorial over n minus r factorial, all right? And what you'll notice is it follows the same pattern for your combination as your exponents. So you have a combination for this one taken to the 3rd. You're going to start with combination of 3 things taken 0 at a time. You will find that is 1, all right? And then you have a combination of 3 things taken 1 at a time. You'll find that is 3. Combination of 3 things taken 2 at a time. That is also 3. And then combination of 3 things taken 3 at a time. That is 1. And so when you use your combinations, you get the 3rd row of Pascal's triangle. 1, 3, 3, 1. What's nice about this is if they want a specific term, then you can jump right to it. What's also nice is if you're doing the 7th or 8th row, that you don't have to write out 8 rows of Pascal's triangle. You can literally just use your combinations to figure out what those coefficients are. And so this is sometimes more efficient if you have even a bigger one or you want a specific term within it. The first thing they actually show us is finding just the coefficient of a specific term. So look at example 3. Find the coefficient of the 5th term in the expansion A plus B to the 7th, okay? The 5th term, when they want the 5th term, they actually subtract 1 from what you're doing. The reason they subtract 1 is you start with 0, right? So you have the combination of n things taken 0 at a time, and then 1, and then 2, and then 3, and then 4, right? And so if they want the 5th term, you're going to take that 5 for the 5th term, and you are going to subtract 1 to figure out what your R is for your combination. And so you're going to use the 7 as your N and the 4 as your R to find out what that coefficient is. And you're going to say, well, it's a combination of 7 things taken 4 at a time. 7 things taken 4 at a time. So the coefficient for this one is just going to be, when you multiply that out or when you put it into your calculator, you will get 35. All right. Now this is because we have an A and a B. We're going to do one where it's not just A and B, where it has coefficients in front of those. But if you have no coefficients, you're just going to take combination of n things, your 7, subtract 1 for this for your R. 7 things taken 4 at a time. So really quickly find the sixth and the third term for those two binomials that they've given us. All right, check your work. For A, for the sixth term, it would have been 126. For the third term, 78. Look at example 4. Find the coefficient of the x to the 7th y squared term in this expansion. Now, when they give it to you this way, they've actually given you what you're looking for as far as your r. Your r is going to be the exponent of your second variable there. And so if they have given us this y squared, that is the r, because y has gone from 0, 1 to 2. So it's actually the third term, right, in that binomial expansion. 0, 1, 2, all right? So they've already subtracted the 1, basically, for you. They've given you what your r is in your combination. And so for the combination piece of it, we're going to say n things, which is my 9. And then the r has already been given to me by my exponent on my second term. 9 things taken 2 at a time. And when you do that, you get 36. But we're not quite done, because in this particular one, we have a 4x and a negative 3y. And so we have to plug those in. We have 36 in front, but we also have a 4x taken to the 7th power and a negative 3y taken to the 2nd power. So we have to actually do those out. So we have to say 36 times 4 to the 7th times negative 3 squared. And then we're going to have x to the 7th y squared. When you do that, you get a really big 5,308,416 coefficient.
How come we did y combination of 2?
Because
Or 9, sorry, not y.
9 is what my n is right here.
Right. And then how come you use just your y and not your x?
Because if I'm looking for the term, I have already gone x to the 9th, y to the 0, first term. I've gone x to the 8th, y to the first, second term. And I've done x to the 7th, y to the second, third term. So just like we did before, the third term is going to be 3 minus 1 to figure out what my r is, 2. They've already done that here. They've already given it to you. I mean, you could do 9 minus this term to figure out what term you're on as well, but it's just kind of handed to you when you do that. Right? So given the formula, combination, n is going to be your total things that happen. All right? X is going to be how many times you want it to happen. P is the probability of what you want happening. And so you're taking that to the number of times you want it to happen. And then Q is what you don't want to happen probability, and you take it to the total minus that X. All right? And so if you have that formula, you just figure out what's what. All right? So let's look at this. We know we're going to have a combination. It says the probability that Andres gets a hit when at bat is 1/5. The probability that he gets a hit is 1/5. All right. What is the probability that Andres gets exactly 4 hits during his next 10 bats? So how many bats total is he going to have? 10. That is your N. All right. How many hits do we want him to get? Exactly how many hits do we want him to get? 4. That is your X. The probability that he does get a hit, that's what we want. So what is that probability? They gave it to us. Yeah, it's 1/5. And we're going to take that 1/5 to that 4th power. The probability that he doesn't get a hit. Well, if he does get a hit is 1/5. The probability that he doesn't is 4/5. Those should always add up to 1. Okay? All right? Your probability of something happening and something, the opposite of it happening, should always add up to 1. Happening and not happening, right, is going to be 1. So this is going to be 4/5. And we're going to take that to the 10 minus 4. That's 6. So that means these exponents should always add up to this 10. All right? The 1/4 and the 4/5 should add up to 1. The exponents of your 2 should always add up to your total. All right? And when you plug all that in, you get approximately 0.088. For percentage, we're going to round that to 8.8%. Multiply by that 100 there. All right, check your work. Exactly 3 heads. They gave it to us as a fraction, 7/32. But if you were to write it as a percentage, you would have gotten 21.9%. All right. For B, exactly 6 tails rather. They all, again, wrote it as a fraction, 7/64. But in percentage, you would have gotten 10.9% there. Expanding a binomial, instead of using Pascal's triangle here for these coefficients, you are going to use your combinations, starting with your number that you have and 0, and then working your way up for your R. You'll notice this stays the same, the N stays the same, but combination of how many things at a time changes. And then your exponents do exactly what they did when we did it before. They start at the highest and go down, and then 0 and go up for those 2. So let's look at example 6. All right, so we're going to do exactly what we did with Pascal's, but instead of the triangle, we're going to say the combination of 4 things taken 0 at a time. And then we're going to have 3x to the 4th, negative y to the 0. Combination of 4 things taken 1 at a time. 3x cubed, negative y to the 1st. We're going to do this all the way until we get 4 things taken 4 at a time. And when you take those combinations, you will get Pascal's triangle. That's what you'll get. But instead of having to write it all out, you can just plug in your combinations for those exponents. You still have to take the 3 to the 4th power and the negative y to the 0. You have to take the 3 to the 3rd power, negative y to the 1st. So you still have to do all of that. But you don't have to write out Pascal's triangle. Once again, when you have a negative in there, you'll notice that it flip-flops from positive to negative. So you want to pay attention to your positives and negatives when you have one. But other than that, it's exactly the same as what you did with Pascal's triangle. Homework.